Hello. Hey guys, how are you doing all? I hope you can hear me. Just let me know if my voice is audible or if it's too loud. Great. How have you all been so far? So we have people joining in from India, Iran, Denmark, Australia. I really appreciate it. Spain, Indonesia. Awesome. Thank you all for joining us on a Saturday. I hope you all are having a great weekend. We will start soon. Meanwhile, you can turn on your Rhino and Grasshopper environment. Okay. So we have people from Mexico. Some of you are asking if this video will be recorded and uploaded. This is a live stream, so you can, like, once we are done with it, you will eventually use the same link and you can watch it whenever you want. Okay, the same YouTube URL. Okay, great. Okay, so you can see some people are trying to register now, but you can go to the webinar webpage. I'll show you in a moment, and you can download the resource files. Okay, the link is in the description. Awesome. Lithuania, Turkey, Houston. Great. All right, so yeah, I think we should start because for people who are joining a bit late, of course you can watch the recording later on, and I'll try to go as slow as possible, but if there are certain steps that you don't understand, you can pause the video and try to follow it on your own pace, and you can write us an email or just contact me on Instagram and just let me know if you have any questions. All right, great. So let's start. Awesome. Well, first of all, thank you very much, guys, for joining us. I hope everyone is safe and sound, and you're full on with your design career, and good luck with all the future projects that you will have. Apart from that, let me just present myself. I'm Aman. I'm from India, but I've been living in Spain for the past 7 years. And like some of you guys, I have studied industrial design. And after I finished my bachelor's degree, I was working in Madrid. And then I started my own design studio with a friend of mine. If you are interested, you can check our webpage. Some of our projects are uploaded here. And apart from that, I also have this web journal where you can see all the different things you can do with Rhino and Grasshopper in general. Okay, so it's a portfolio of all the possible stuff you can do with Grasshopper. Great. And finally, we have Academy, where I'm giving classes to teach about Rhino, Grasshopper, some advanced Grasshopper stuff, and KeyShot. So first of all, you all can head to the webinar webpage, which is academy.xyz/webinar2. You will also find the same link in the description. Okay, and here you can download the exercise files. Okay, so let's click here. It should pop up this drive folder that you can download. Okay, so there are 3 files. The first file is about Rhinoceros, the second Grasshopper, and the third KeyShot. Okay, so what will we do? We will start with Rhino, where we'll create the generic shape of the trimmer. Then on certain parts of the trimmer, we will apply a texture using Grasshopper. And finally, we will export the geometry to KeyShot for rendering. Okay. Meanwhile, if you guys have any question, you can just leave it in the descriptions or in the chat, and I'll try to answer one by one. All right. Towards the end, we will have some time so you can ask more questions. But meanwhile, let me know if I'm going too fast. I'll try to slow down. Okay. Great. Some of you are asking if the video hasn't started right. Can anyone see a video yet? I hope all of you are seeing the video. Maybe try to refresh your screen. Try refreshing. But rest of you all can see the video, right? Hello? Yes, okay, sorry. There is a lag, okay? So sometimes if I'm not replying at the moment, just ignore. Great, so once you have downloaded the folder, let's import that folder. Let me just grab the folder here. Okay, so we have this folder. You can right click and extract the contents of the folder to this big folder. Okay, great. So you will see that we have these three files, the Rhino, the Grasshopper, and KeyShot file. Okay, so let's start with the Rhino file. So I'm going to open my Rhino workspace, and let's go to Files, Open, and let's just find our webinar folder and open the Rhinoceros file. Okay. Great. So you will see that there is this generic technical drawing of the trimmer. And if you go to the perspective view, you will also see that I have set up for you guys the images so that we can now trace the shape and create the geometry. All right. You will also see that in the layers tab, I have added the different steps. Okay. So you still have the curves and you have all the steps that we will follow along. Okay. Just for reference. But let's try to do it on our own without the help of the reference shapes. But we will sometimes turn it on and off to understand what is happening. All right. Great. So the first step is going to be creating the curve of the shape. Okay. So I'm going to go to the front viewport. Okay. And here you can see that we have the profile. So I'm going to create a new layer called trimmer profile. And you can double click to activate that layer. All right, so we will start to draw the profile using control points. So let's turn on this command. The degree is set to 3. All right. So let's start by creating the first point in the center of Rhino. Okay, so you can do that by pressing 0. Okay, and you can see that my point, the initial point, is snapped to 0, 0, 0 of Rhino. Okay, and just try to trace out the shape. Okay, let's just add more control points. Okay, so just try to extend the curve a bit away from the geometry. Okay, and we just have to worry about the this half, because the other half is just the symmetry of this half. Okay, so once you have the curves set up, we will now manually calibrate the curve. Okay, so you can select the curve, turn on the control points, and then you can move these points in order to put these curve in appropriate positions. Okay. All right. So we have a generic outline of the trimmer. Okay. We will see how to kind of position these points and how does it affect our geometry once we have kind of created the other parts. Okay, but for now, let's leave it like this. I hope you guys are following along so far. If you have any question, just drop them down in the chat and I can try to revisit your doubts here. Okay, so once we have the curves set up from the front view, let's move to the right view. Okay, so for the right view, just go here to the right viewport. And now you just have to kind of adapt this curve so that it follows the shape of the trimmer. Okay, so I will not be touching the last 2 points. So I will just try to adapt the rest of the points to the shape of the trimmer. Okay, so let's just first, because when you're working with control points, everything is not so easily predictable. So generally I will position all the curves, all the points more or less, and then slowly calibrate it. Okay, so let's move this control point. Okay, somewhere around there. Great. And finally we have it. Okay. Again, if you're having difficulties, just try along with me. And if not, then you always have the curve layer where you can extract the original curves. So once we have the side profile set up, okay, so from front view it looks exactly like that. Okay, and from the right view it follows the curvature of the trimmer. Okay, now we have to add the side 2 curves. Okay, so let's start with the front curve. Again, degree 3, start of the curve is 0, 0, 0 of Rhino, so I'm gonna press 0 and enter. And then you can start to draw points. Okay, so let's add a couple of points here so that you can kind of adapt to the shape of the curvature of this geometry. So a good trick is that the least number of control points you use, the better it is. Okay, in general, I mean, I'm trying to generalize it here, but yeah, the less control points, the less kind of deformation you will have in the curve, and your curve will be a lot more smoother. Okay, so like every time, just try to calibrate the shape. Okay, more or less like that. Okay, there are some tools in Rhino that you can use to kind of see how the curve is taking shape. So that tool is called Analysis Curve Curvature Graph. Okay, select the curve, press OK, and you will see that it will draw this hairline structure that you can change the scale and density. Okay, and this kind of will give you a generic representation of your curvature acceleration, and if you have kind of smoothed out the curvature properly or not. So you can see that when you move this, let me just increase the scale so that you can see the effect of the curvature exaggerated. Okay, so you can move these control points to kind of get a really even acceleration. Okay, so even though if you just see the curve, you might see that it's pretty smooth, but if you now exaggerate the deformation that the curve has using the curvature graph, you can see that you have a lot of work to do here. Okay, So I'm just gonna position these control points so that we never get like a negative deep inside there. Just position it here. So that is more or less a good start. Okay, and let's repeat the same process for the backside. Select the curve, start is 0. The red lines affect the 3D model. The red line affect the 3D model? No, doesn't. Okay, and Fixate says it would be far less kinky if you built it with degree 5 or degree 7 or degree 9. Yes, of course. But we are gonna just do it with degree 3 and draw NURBS curves. Okay, so again 0, then start adding control points. Okay, something like that. Again, like last time, try to move these control points so that you get the generic shape of the curve. Okay, I hope everyone was able to follow along so far. Great. Let's see how does the curve look in the perspective view. Okay, so we have these two curves in the YZ plane, and then the side curve is not exactly in a single plane because we have deformed it. Okay, now the last step is gonna be creating a reflection of this curve on the other side. Okay, so you can turn on the mirror command, select the curve, and then just draw a line that starts in the center of Rhino. So you can press 0, and with the shift key you can just draw a plane that is going to reflect in the Y and Z plane of Rhino viewport. Something like that. Let me just hide the image so that you can see. Okay, great. So let me know if you have more questions. Fixate says that multi-span degree 3 curve don't have G3 continuity, of course, between the spans. Yes, they don't have the G3 continuity. All right. So once you have these 4 curves, we are gonna create the cross-sectional profiles. Okay, because now we will draw the curves that are in the V direction. So these are the curves that are in the U direction. Now we will draw the curves in the V direction. Okay, before I do that, let me just turn back on the curve command, and let's just get rid of the extra parts that we have. Okay, we can do it now or we can do it later. It's fine, it's the same. You can either draw a curve, rotate it 45 degrees in the negative side, so negative 45. Position it somewhere around here, and then you can split these curves with this curve. Okay, both the curves, this curve. Okay, so we can get rid of these 2 points. It is going to create a problem with these 2 curves because they're not in the same plane. So you can either extrude and then intersect. Okay, I have extruded that curve, and then I can split this and this with this surface so that you can get rid of these extra additional curvature. Okay, so once you have set up till this part, let's create the V direction curves. Okay, So I will be using a command called curve from cross-section profiles. Okay, so basically here you select the curves in order. So this is the first curve, second curve, third curve, and fourth. So you either select it clockwise or counterclockwise. Okay, so once you have done that, press enter, and then make sure about two things. The first thing is make sure that the cross-section profile that it's going to generate is closed profile. Okay, so make it yes, and then you have to head to the right viewport. Okay, and here you just have to start to kind of slice using lines the geometry. Okay, so click, 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 and then the last one like that. And you will notice that we have created these cross-sectional profiles. Okay, so let me know in the comment section, do you have so far the geometry? Or do you want me to explain any part of it? Probably there is a lag between what I'm saying and what you guys are seeing. But eventually, if you are kind of lagging behind, Netik is asking how to trim the top part. So the easiest way is to just draw like a surface like this, okay, using the same curve. So let me show you one more time. Okay, I'm going to extrude this curve straight in this direction, both sides. Okay, so create this surface, and you can use this surface to trim the extra part of the curve. Okay, split. Okay, and then you can split these curves using this surface, and then you can delete these extra parts. Okay, and then generate the cross-sectional profiles using this command, curve from cross-sectional profiles 1, 2, 3, 4, and then go to the right viewport and start drawing the cross-sectional profiles. Okay, like that. Awesome. Yeah, the cross-sectional curve tool is pretty handy to generate these wireframes. So on one side you have the U curves. Okay, let me call them U curves. And on the other side we have the V curves. I mean, you can call them interchangeably, it's fine. It's just that one is different than the other. Let me just rename. Somehow it's not letting me have a command turned on. Okay, V curve. Okay, so let's select one set of curves, put them in the U layer, can color it red, and then the other set of curves, select them, and then in the V layer, change the color, set to blue. So here you have the U and V curves. And to generate this surface, we will be using a command called surface from curve network. Okay, so this command will take your curves in U direction, your curves in V direction, and it will give you a surface. I'll repeat. So this surface from curve network command will take your U curves, your V curves, and it will give you a surface at the output. Okay. The only thing is this particular spot that you will see that there are some problems. Okay, if I just go to the rendered viewport, you will see that it doesn't look pretty clean. And that has to do something with how we have resolved the continuity of this curve. Okay, from this curve to that curve, from this curve to this curve. So we have to kind of clean that part. Okay, so what I'll ask you to do is turn on the control points of all of these curves, and you will see that all the last point, they are in the same spot, so that's great. However, we would like that the next set of control points of each curve, they all are in the same plane. Okay, so you select these set of control points. Okay, so you select all the three plus this plus this. Okay, and we want all of them in the same plane. So you can either do it using this gumball, or you can use a command called set points. Okay, so the set points command will pop up this window that is going to ask you to set in which axis. So in our case, we just want to set the points in the z-axis. Okay, and you can see that I can move these points only in the z-axis. Okay, press 0 and enter. Okay, so this step will take all of these control points plus all of these starting points and put them in the same plane. So this will help you create a surface that is at least tangentially continuous on this part. Okay, so let me just flip it, and now you can see the rendered viewport. This looks a lot cleaner. Okay, we can still resolve some things, but it's a good start. Okay, so what I can also do is just hide these reference curves, and you can turn on the original curve if in case you are not able to follow along so far, and just rerun the command. Okay, surface from curve network, select everything except this line. Okay, so I can select everything like that except this part. Okay, and you should get this surface. Just make sure to set the tolerance to 1, because if you set lower tolerance, Rhino will add additional subdivisions, and we don't want that. Okay, we just want a really smooth, simple surface as possible. Okay. The command that we use for creating the surface is called surface from curve network. All right. So what I generally do is whenever I have a geometry, I will move it, let's say by 50 units or 100 units. Okay. Then I will do the operation whatever I want, and I will move it then by 100 units. So each step that you do, you are kind of creating a backup copy of the geometry. Okay, so this is gonna save you from, let's say you mess up your file, you can go back to the previous step and resolve the problem. Okay, so now it's just some simple steps, okay, that we have to follow. So you can turn on the poly surface layer, and you can see what are the next steps that we have followed after this. So the first step is creating these cut marks, okay, that we have here. Turn on the image layer. So these additional geometries. So I'm just going to create a curve that is straight, then rotate this curve by 45 degrees, Okay. And then just create some additional copies of this. Control C, Control V, Control C, Control V, Control C, Control V. Okay. So I will use these 4 curves to cut this shape into multiple small segments. Okay. So before I do that, I need to make sure that this shape is a closed poly surface. Okay, so you can do that by running the cap command, cap. So it will convert this open surface into a closed poly surface. Okay, because this hole is a planar hole. Okay, and then we will just use these lines as a way to cut or split this shape. So you can see here we have these individual shapes. Okay, so once you have those individual shapes, like here, okay, and then we will also create this back and front side part. So I don't need to explain these like really simple steps, because these are just creating additional plane, cutting the or splitting the shape from front and back. Okay, you can do split these 2 geometries, front and back, so you get the back and the front geometries separated. Okay, and once you have them separated, I will just show you guys here, you can apply fillet. Okay, so the first thing, let me just move it by 5 units. This one has 5. This step don't need to follow along, just understand what I'm trying to do here. You can add first solid fillet, and then you can add fillet over here, okay, over here, and over here. So we added a fillet of 2 millimeters on each corner. And then if you want to add fillet on this profile, let's repeat the command, solid, fillet edge, fillet, and then just make sure that this radius is lower than 2, okay? And we don't want actually too much radius, we just want to kind of separate these 3 geometries, like visually. So I'll just add a 0.5 millimeter radius. You can also use chain edge to select the entire sequence of edges. If they're tangential, they will automatically be selected. So Srikesh is asking, okay, so we have a couple of questions here. We have, how do you get a surface with 2 colors, 1 on each side? So this is something that you will be able to see in the shaded view. To change that, you have to go to document properties, go to view, display modes, shaded, and you need to change the shading settings to set the backface setting to a single color. Okay, so that you will see all the backside of your surfaces in the same color. Okay, display, shaded, backface setting, single color, set it to magenta or something like that. Okay, apart from that, Srikesh is asking, your speed of explanation is good, really appreciate that, thanks Srikesh. Sorry, beginner here, what's the difference between surface and poly surface? Okay, so the difference between surface and poly surface is in the name. Surface is just one surface. Poly surface is that when you join multiple surfaces together, it becomes poly surface. Yes, a poly surface can be open or closed, okay? Depending upon what kind of operation you would like to do, you would want to make it closed or open. Okay, so once you have applied these fillets, okay, you can see how does it look in the rendered viewport. So when you have these fillets, it looks a lot better than when you have sharp corners, of course. And you will get eventually a result like this. So in order to apply the fillet, what I do is generally move these geometries by 1 or 2 units. So this was moved by 2 units. This one also was moved by 2 units, because it's a lot easier to work when they're separated than when they're like, you know, sharing the same edge. Okay, it creates confusion. That is why you see them flying away, but they're strategically moved 2 or 3 units up or down. Okay, and once you have applied the fillet, you can bring them back to their original place. Now it's time to apply the blades. So basically you'll take this shape, move it up by, let's say, 10 units or 50 units in total. So move it by 50, rotate it by 45 degrees to make it planar, because every shape of our geometry is inclined by 45 degrees. And then you can use this predefined shape and fuse it with your geometry. Okay, -100. So you have this shape and this shape in the same, almost in the same plane. And I'll try to kind of create a single shape with these two. So I'm just going to move it away from my shape. It's easier to work like this. And just create a rectangle. Something like that. And you can then extrude it. Not both sides. And join everything together. Okay. So if you have done it properly, you will be getting this geometry at the output. Okay, so again, I have done this for you guys. You can see we have this shape. Okay, and you can select these 3 shapes together. And in order to combine them as a single solid, you can use Boolean union. Okay, and then I have just added a plane in between using the same curve. Okay, you can use the same curve like here. I have created a surface like that. Okay, and then you can use this surface to split this geometry into 2 halves. Okay, so you can practice it by going to this part of the geometry. Okay, use the Boolean split command to split this shape into 2 shapes. All right, so that eventually you can get this half mark here on both sides. Okay, and yeah, you also need to apply the fillet, so don't forget to apply the fillet. Solid, fillet, and set a low radius. So in this case, you can see it's giving me some problem because my radius amount is high. So let's go to solid, fillet edge. Set the radius to something like 0.25. And there you go. The same here. Okay. So you can see that we have these 2 poly surfaces. Yeah, you can set the distance between the distance between the 3 parallel blades by moving them by 2 units, then 1.5, and then 2 units. Okay, so once you have this generic shape, of course in combination with the blade, now we have to add this lift in the shape. Okay, so for that you can check this curve. okay, that we have drawn. So again, you can trace out this curve using the outline, and like last time, we are gonna make, just block the image. Yeah, so like last time, you are gonna make these points in the same plane so that you don't have any problem with continuity of the other half. Okay, so you will use these curves, okay, these curves to project it on the shape, okay, like that. So I'm going to repeat it with you guys. Let's go to the front viewport, select the curve, create a copy, Control-C, Control-V, and then we will scale it down to create the transition. Okay, a bit more, something like that. Okay, so we have these two curves, right? And I will project these two curves on the geometry. So you can go to front viewport, project curve 1, curve 2, press OK, geometry, press OK. And you should have the curves projected. Okay. If you don't see the curves projected, just make sure that when you choose the direction is set to view, so that depending upon how you view the geometry, the projection will happen. So if you view it from the front viewport, the projection will be in this direction. If you view it from the side viewport, the projection will be in that direction. Okay. So once you have this two curves on top of the geometry, we can then split our surface with these two curves. Okay, so let's run the split command, select the surface, curve 1, curve 2, press OK, and then you can get rid of the intermediate part. Okay, so you have this shape that we carved out from our original surface. Okay, and we will just move this surface slightly outside. So you can just rotate the surface just by maybe 1 degree or 2 degrees. That's more than enough. And then we will try to kind of create the surface between these two geometries. Okay, so the easiest way that we can do is using a command called blend surface. Okay, so select the curve, second curve, and then you press OK, and it's gonna pop up this window that is going to help you kind of determine how this transition is happening. Okay, I'll repeat. You will use a command called blend surface that is going to blend this trimmed surface to this trimmed surface. Okay, let's move this knot here, this one here, press OK, and then you can control these settings. So these are a bit more advanced controls, like how would you want the continuity between your original surface and the target surface to be. You can change here. Okay, you can fine-tune it depending upon your needs. Okay, you can also use this add shape command to add like intermediate shapes. That can help you create better transition between these two geometries. Okay, and once you're done, you can press all right, and there you have the transition shape. Okay, I have also prepared for you guys a different way of doing it. So I have created these two profiles. and then I have also added these two curves. Okay, so you can use another command called surface from sweep to rails, where you can use this as one rail, this as another rail, and these two green curves as cross sections, and press OK. So it's going to create this interesting surface. Okay, so probably you can use this as well. I just need to select closed sweep to kind of make it go all the way around. I'll repeat: surface sweep to rails. Okay, curve 1, curve 2, cross section 1, cross section 2. Okay, you get the shape. Just make sure to close the sweep. Press OK. So this is another way of doing it. And if you would have your surface as well here, you can also use probably the surface edge to match the continuity, but these are some advanced stuff, so just try to follow along as far as you can, but you can investigate more about how to do these continuity operations later on. And finally, you will have a geometry that looks like this, and that you can join with the rest of your shape. Okay, now let's see what else can we do here. Let me just see if we can have more questions from here. Srikesh is asking, so the design rule is that subsequent fillet have to be smaller than the previous, is it? Yes, exactly. So if you have a, let's say, a cube, you do solid fillet, maybe 30 units. So now if I have to fillet this particular edge, solid fillet edge, if I set it to anything that is 30 or above 30, let's say 32, it's gonna give me some problem, you can see. But if it's smaller than 30, even 29.9, it's gonna work. Okay, so surfaces need for the fillet, the corner fillet, they need 4 sides, as you can see. So by leaving this really small edge, you're actually giving it the 4th side, so it kind of works. All right, so now let's apply some kind of texture to this particular face, this face. Okay, so I'm going to open Grasshopper. You can click on this button, or you can write the Grasshopper command. Okay, so it's going to open this pop-up window. You can just dock it right side. And yeah, I mean, if you're barely starting with Grasshopper, so it's going to be a bit difficult to kind of follow along, but we do have more webinars in our channel. You can watch it, as well as we will be uploading more stuff, so you can follow along. So we will be applying texture to this particular face. Okay, so I'm just gonna deconstruct the face on polysurface so that I just have this particular face with me. Okay, so you can even get rid of these by moving them away. So I'm gonna import this surface in Grasshopper. Okay, so let's add a surface node. You can double click and write surface and try to find the node that looks like this. Okay, so this can import surface from Rhino viewport. Okay, so to do that, you just right click, set one surface, and reference this surface. Okay, and you can see it looks like this red color object. That is because you have your original surface overlapping the Grasshopper geometry. So you can either hide it, okay, or you can hide the viewport here. All right, so we are going to apply some kind of texture to this shape. For that, we will be using a component called surface frames. Okay, so surface frames will help you generate frames on surface. Okay, so let's go to surface, utilities, surface frames. And when you connect the surface here, okay, you can draw this cable. You will see that it has created some number of frames on top of the surface. Okay, if you don't see these frames, or if you see these frames really big, you can change the display of these frames by some amount. Okay, you can make it bigger or you can make it smaller. All right, and then you can add counts. So you can double click, and let's say you add 25 counts in the V direction, and then maybe 60 counts in the U direction. Okay, maybe that is too much. Something like this. Okay, so what are frames? Joachim is asking, this add shape are also something great to implement in future projects. Okay, oh sweet, great. So what are frames? So if you look closely on any of the frame, it's basically like a C-plane. Okay, you have like the X and Y axis, and then you also have the normal direction. And if you add a panel to the frame output, you will see that whatever geometry that you get here, okay, it has an origin, which is like the physical coordinate in 3D space, and then a normal axis, a normal vector for that particular point. Okay, it's a bit complex, so you just try to think that we are creating like these placeholders on top of the surface that are oriented normal to the surface. Okay, because you can see here that the frames that are at the bottom are kind of aligned to the surface at the bottom, and on the top they are oriented in different direction. Okay, and we can use these frames to put any geometry on top of there. Okay, so let's create circles on top of those frames. So let's create this circle component. You can find the circle component in the curve, primitive, and then the circle component is here. So we will create these circles on those frames. Okay, and you can see we have added the circles here. Okay, a couple of things to do. The first thing to do is we need to hide the frames because we don't need to see it. So to hide a node in Grasshopper, you just select the node, press middle mouse button, and you hide it. Okay, so you're not seeing the frame. It's still working, it's giving output, but you're not seeing it. And the other thing that we will do is that you will see this cable, which is a complex data tree that is being flown through the cable. We actually don't want it. So we have to do an operation called flatten. Okay, flatten tree. So flattening the tree will change the data structure from something that looks like this to something that looks like this. Okay, this is a simple data structure. Or if I show it to you in a graphical way, before it was looking like this, and once you flatten it, it looks like this. Okay, so we are basically putting all the frames in the same simple list. Okay, once we flatten it, so we just want a flatten list, okay, where we are creating the circles. And you can use the radius value, let's say 0.25, and you can control the radius of all of these circles. Okay, and as this is a parametric model, you can go back anytime to the surface frame U and V count, and you can increase if you want more or less circles. Okay, I hope till this part things are clear. Let me know if you have any questions. Great. So we are almost there with Grasshopper. The last step is the following. You will see that some of our circles are touching the edge corner. Okay, so when I'm trying to fuse this surface back to my original geometry, if I have any kind of operation on the edge, it's gonna be giving me a lot of problems. Okay, so what I need to do is I need to kind of create a system in Grasshopper that is able to filter out all the curves or all the points or frames that are close to the edge of this surface. Okay, so let's see how can we do that. So the first thing first, we need to extract the edge of the surface. So you can use a command called brep edge. Okay, you can go to surface, analysis, you have the brep edge, right? You can see that it extracted my surface edge here. Okay. What if you want strength vertical lines instead of UV circles? Straight vertical lines instead of UV circles. In this particular spot, you can do, let's say you can create like a line, or let's say a polyline, or interpolate between the frames. Okay, it is giving you an error, but you can ignore the error because you're kind of giving it some empty list, that's why. But you can see that you get these vertical lines. And if you want to get the horizontal lines, you can flip the matrix. These are some advanced operations, so just I'm just showing you the flexibility of Grasshopper, but in this maybe they're not aligned the way I thought they will be. That is why it's creating this weird structure, but for straight line it works. Anyway, yeah, it's not gonna work for the other side because you have different amount of lists. Anyway, so we have the curve here, and we need to compare whether this point, this frame, is close to that edge. Okay, can you control and change the spacing between the frames circle? Yes, of course. You can see here that if I change the count in U direction, you can make it less spacious in this direction and in the other direction as well. Okay, so you can change the space. You can also create some parametric way of doing it, but for now we're just trying to do it fast and see, like, you can manually calibrate it. All right, so here, once you have the cable, the edge, let's compare. Let's add a point container. Let's compare. Okay, just make sure that you never take anything from the frame part. You always take it from the flattened part. Can we put the surface along, can we put the circles along the surface edge? Yes, James, we can do it, but let's first do this and then I can explain it to you how to do that as well. So let's compare these points to these curves. Okay, so there is a command called pull point. Okay, so this component can pull these points to this curve. Okay, so when it pulls any of the point to the curve, it calculates the distance it had to travel to pull the point. Okay, so that's a good value that we have. So now we can kind of compare the distance of each point. So if in any case the distance is low enough, we can get rid of those points. Okay, so let's see. So first you get the distance. So let's compare whether a distance is lower or larger than certain amount. Okay, so you can use an operation in mathematics called larger than or smaller than. Okay, so we can say if any of the distance is smaller than, let's say, 2.5 units, it is telling me whether that statement is true or false. Okay, so if one point is smaller than, or the distance between that and the curve is smaller than 2.5, it is telling me true, and if it's larger, it's telling me false. Okay, so we can use this true and false statement to kind of separate from the list of points one list that is close enough and one list that is far from this value. So for that, we will be using a component called dispatch. Okay, so what is it that we would like to dispatch? We would like to dispatch the circles. Okay, and well, I think it's better if we dispatch the frames actually, because it's gonna be a lot more helpful. So I'm gonna dispatch the frames. Let me just show you in this way. Okay, so I'm going to dispatch the frames using this pattern. Okay, and you won't be able to see any difference yet because you're seeing both the planes here. So you just need to add a plane container here, so you can see all the planes that are close and all the planes that are far away, and hide this component. So now you can see each plane that was close enough here was eliminated from the list. Okay, let's hide everything else. And then we can create a circle on those planes. Okay, and then you can use this value to kind of calibrate whether you want these circles or not by changing this value. Okay, I know it might be a bit confusing, but I'll repeat. We start with the surface, we draw frames. We flatten the list because we don't want to work with data tree yet. And we take the surface and extract the edge of the surface. And we compare these frames or these points to the edge of the surface. And based upon the distance, we filter those frames in one list and the other list. And on that list or on that frame, we draw the circles. Okay, so we can change or control how much amount of circles we want in our list. Okay, let me see if you have any questions. Any questions, guys, meanwhile? Okay. Anyways, so once you have the circle, we need to extrude these circles. Okay, so let's extrude them. And the direction in this case is actually our plane itself. Okay, so Grasshopper is intelligent that when you connect a plane, okay, as a direction, it understands that you would like to extrude the geometry in that particular normal direction. Okay, and you can see it works. And you can control the height by multiplying the plane vector with, let's say, negative 3.0 to positive 3. You can control whether you would like it to go negative way or the positive way. Let me see why it's not. Okay, most probably, let me see if I can translate it into a vector first. And then it works. Yeah. So you can make it protrude inwards or outwards. Okay. And finally, you can use the cap command to convert these circles into solid geometries. So I will start by reducing the number. Always try it with low number of geometries, and once you see it works, you can then bump up the count, and you can see it works. We have at the output closed B-wraps. Okay, so I'm just going to increase the numbers, 70 in this direction, 100 in this. Okay, and you can see it works perfectly. All right, so once you have these geometries, in order to bring them to Rhino, you have to bake them. So to bake a Grasshopper geometry, because it doesn't exist in Rhino, as you can see, I cannot select it. You need to right click and then bake that geometry. So it's going to ask you in which layer you would like it to bake, as well as would you like it to group together. So I'm going to say yes, I would like to group it together. Press OK. And there we go. We have this geometry then that we can use to remove from our closed shape. Okay. So if we have it over here, as you can see, just gonna move it slightly in this way. I can use this shape to remove it from my base solid geometry. Okay, just gonna give you some really fast demo. So let's just ungroup it so that we can do it one by one in small batches. So it's calculating its a complex task. As you can see, it takes a while to do it. But meanwhile that I'm calculating this, you can ask me any question in the chat. Some of you are asking, I used to measure the distance extracting point from curve and then using the distance between point command. Pull point command is incredible. Yes, the pull point command also, the another thing about it is that you can use multiple geometries, not just one. You can put as many geometries as you want, and it will filter without any problem. Then Carlos is asking, hi, the percentage shown on the bottom of the function represent what exactly, and how can you display that? So as you can see, some of my components show this percentage. So the percentage is actually how much resource this component is taking in the entire definition. So the last component is taking almost 80% of the computational resource, or if you double click, you can see how much time it takes. Okay, you can turn this on by going to display, canvas widget, and turning on the profiler. Okay, so as you can see, I'm slowly removing these shapes from the geometry. Okay, one last step. And you have the final geometry, as you can see here. Now we have this texture applied. Okay. Someone is asking, can we define two sizes and make the grasshopper make a fade in out based on those two circles? Yeah, you can do that. You can first directly do this without using two circles. I mean, you can just create a gradient of radius. So instead of a fixed radius like here, we can use as many number of radius as there are planes. So I'll just show you, you don't need to follow along this part. So I'm gonna filter the, let's say, the distance as well using the same pattern, and in the list B I have number of values. Okay, so the list is a number, and I can use this number to calculate the radius. Just I will make it a bit smaller. Again, you can see here how I am able to control the radius based upon the distance. Okay, so if the circle is closer to the border, the radius is smaller, and if it's closer to the center, the radius is higher. Okay, so you can do really simple, not simple, but complex operations like this, but with simple steps in Grasshopper. Okay. All right. So once you have that shape, so you can use the last one that I have already prepared for you guys. And in this case, I have used a different shape. You can check the Grasshopper file that I have attached to see how I created this shape. Okay. And then we will save this geometry to render in KeyShot. Okay. So we created the geometry in Grasshopper, sorry, in Rhino. We applied the texture in Grasshopper. Once we are finished, let's export this for KeyShot. Okay. So just select all the shape, this one using this rectangle, go to files, export selected, and then let's create the file format. I have seen that KeyShot is giving some problem with Rhino 7, so you can use Rhino 6 and just rename it. Okay, and you will see that we have exported just that geometry only. Okay, now I have set it up for you guys, so you can just open the third file directly. So let's open it with KeyShot 10. Okay, it's opening. Okay, meanwhile, let me know if you have any questions. Which format to export, Natik asks. You have to export it in 3DM Rhino file. You don't need to convert it into any other format. KeyShot can understand native Rhino files. Okay, it's just that Rhino 7 sometimes gives some problem. Rhino 6 is what works perfectly in my case. Probably this has to do with my KeyShot version. Okay, great. So let's open this, and when you open the file, the KeyShot file, you will see this trimmer. Okay, and it has like this really diffuse material. Okay, so let's see how you can render this geometry in KeyShot. Is there any option for pattern the blades? Are you talking about creating the blade pattern in Grasshopper? Because it's pretty simple shape, like you draw the shape and you can copy it multiple times to create the Boolean difference. If you are starting with the Rhino, I will recommend you guys to watch our previous webinar, okay, you can check it in the channel where we create some simpler shapes first. Okay, all right, so here you will see that we have like this really basic startup studio HDRI. Okay, and a lot of people, when they start with KeyShot, they commit this mistake that they're kind of rendering using the default studio, and this is gonna create a really bad quality render because there is no contrast in this studio HDRI. Okay, so you can also check our webpage in resource tab. We have an article, this one, where you can learn how to create this HDRI. Okay, I'll explain to you in step by step, but you can go from something that looks like this to something that looks like this by creating your own studio in KeyShot. Okay, so first thing first, I will be applying a material, plastic material. Let's go to plastic, and let's find this hard rough plastic white, and let's just apply it to the entire shape. Okay, you can just drag and drop like that and it should work. You can also go to the scene tab and you can drag and drop the material here. Okay, you can see the difference, hard plastic white. Okay, Netik is asking, did you use import command in KeyShot or you drag and drop the 3DM file? Well, in this case, you will find actually a KeyShot file. We have just opened the KeyShot file, okay? But the step is exactly the same. You just file, import, and you import the Rhino file directly, and it should pop up. Okay, so once we have applied this material, let's see how we can create our own studio. Okay, so for that, let's go to environment. Okay, and let's create a new environment, a new blank environment. Okay, let's call it custom environment. Okay, and you can see that at the moment our environment has this gray color image surrounding the geometry. Okay, so first thing first, we will change the environment by going to the HDRI editor. Okay, so make sure you're at the HDRI editor and not in the settings tab. Okay, and here let's first bring down the color of the background to black. Okay, in HDRI editor, background color is black. Okay, once you have done that, let's start to add lights in our HDRI. To do that, you just have to click on this button that is add a pin light, and you will see that when you do that, a light has been added to the viewport. Okay, you can see it from the distance, and you can move this light source in the 3D space, and depending upon where you put it, you will see different parts of your trimmer is being lit. Okay, you can press this button here, that is to set the highlights, done, or you can click this button, and now wherever you click on your screen, the point light will put itself perpendicular to the place where you have clicked, and it will set a highlight in that particular spot. So you don't need to manually change it here. You can just click on the shape and it will automatically put itself normal to that part. Okay, so we just have to start with adding multiple light sources. Okay, so I have added the first light source somewhere around here. Okay, so that is our maybe key light. So that's the principal light. Let's add some more light sources. Okay, here I'll add one more over here. Okay, that kind of lights up the shape from backside, and it kind of defines the volume of the geometry. Okay, and if you don't want it to be too bright, you can always go in the radius and the brightness tab to turn down the brightness of that particular light source, or you can reduce the radius. Okay, I hope you're following along so far. All right, so as you can see, we already are getting some decent composition here. Okay, you can keep on adding more light sources, maybe one that points it from the bottom side. Maybe something that lights up this particular spot. Okay, so once you're happy with the lighting settings, you can come back to the settings tab and change the background lighting. Instead of the lighting environment, you can change it to a color. Okay, so you can set a permanent color as your background. Okay, so I'm just setting it to something like grayish in color. And then let's save this particular camera, okay, the camera that you like. And you'll, if you want, you can use one of the cameras that I have already set up for you guys. Okay, so this is the last camera that you can use. Or you can just set up any camera you want and press this plus icon to save it as your own camera. Great. And finally, let's apply some materials to the geometry. So the first thing first, we will apply a metallic material to the blades. Okay, so let's go to metal. Let's apply iron metal here. Let's see, iron polished. Okay, so I'm going to drag and drop it over here. You can see we have applied the metallic material to that part. So I will select all the parts where I would like to apply the metallic material, so which is this part as well. Okay, there you go. And then let's apply two different materials to these two parts. Okay, so the back part I will apply a plastic material. So you can go to plastic, hard rough plastic, the black color, and let's apply this over here. Again, you can see we have this nice black plastic in that part. Okay, and for the front part, let's apply some shiny red plastic. This one, like that. Okay, and you can see if you like the results or not. Okay, so once you have applied the material, I generally recommend you to go back to your HDRI and do some minor tweaking, because you can see everything looks a bit dark, so you might want to increase the brightness of some of your light sources. Okay, I'm gonna make it twice as bright. This one also maybe a bit brighter. This one also maybe twice as bright. Okay, and you can see how does it look now. Okay, you can also edit these materials if you double click them. Let's say this front part is too polished, okay, and you can change the roughness by increasing the roughness amount. These materials in KeyShot are already downloaded. Okay, you will find it inside KeyShot library. It's not created by me. So you can set the roughness to a really low amount, and you can see how it creates like this slight matte finish. Okay, and of course you can change the color to any other color you want. All right, so just try a different configuration of materials. You will also see that there is this cloud library option, and when you click it, it's going to open this cloud library, and you can find a lot of different types of materials directly in the library. Okay, so here is a really big list of materials. So let's try adding this oil slick PVD coating. Okay, let's just download them, and when you press download, it's going to download it in your download material bar, and then you just have to drag and drop this material here. Okay, and you see that material being applied. So Netik is asking his KeyShot interface is totally different. If it's totally different, then just click here on workspace, and then just click on default, revert, and it should provide you somewhere similar user interface. I'll repeat, workspace, default. Okay, and here you can change some of the settings. You can change the coding amount, thickness. These are some advanced settings, so don't worry if you're basically starting with KeyShot. And you can change the roughness as well to get different results. Okay, so what I have done is that I have also included another layer that is this bottom one, and you can go to environment and change the environment to the new environment. Okay, so this is an environment that I have created previously. Okay, and you can see we get this nice render. Okay, and the final step is now to render the geometry. Okay, so for rendering this geometry, let's go to render, and it's gonna pop up this render option. So how do you know the settings for rendering this scene? Okay, so the first thing first, let's define the resolution of the render. So you can go to preset. Let's say you're rendering this for a web page. You are going to render it in 16:9. If you're rendering it for Instagram, you will be rendering it for 1:1. Okay, so you can see when you set it to 1:1, your viewport automatically locks in that resolution. Okay, once you have done that, you can go to render, and here you can set the name. Okay, let's call it render test, place where you would like to save it. Okay, format that you would like to save, so I recommend you to save it in PNG format. And then here you can change the resolution. Okay, maybe you want high resolution or low resolution, you can change it here. And after that, the next setting that you have to do is in the options tab. Okay, so this is pretty simple geometry, so you don't see the difference yet, but in certain cases it's going to take a lot of time for the render to happen, and for that you need to set samples. Okay, so what are samples? So if you press the edge button. Okay, you can also turn on the heads-up display, edge. You will see this window pop up, and on the third line you will see the samples parameter. So whenever I reset my viewport, you will see that the samples start from 1, 2, and they progress. And as they progress, you will get a better render quality. So actually this is the sample number that you have to provide here. Okay, so you can let it sit for a while. Okay, so I'm gonna let it sit. Okay, maybe 10 samples already look pretty nice. There are some noise over here, so I'm just gonna wait a couple of more samples. Okay, maybe you're not able to see it because of screen brightness, but around 40 samples, it's really great. So I'll just bump it up by a little bit. I'll set it to 50 samples. Okay, and once you have set the samples, now you just have to press render. Okay, so I'm just gonna press render, and there you go, it's now rendering. Alright, so this is a really typical workflow on how you can model geometry in Rhino, apply textures in Grasshopper, and then create the render in KeyShot. Okay, and you can do some post-production here as well. What if we provide low samples? Then how does it affect our render time? If you provide low sample amount, you can see your render will happen a lot faster, but your quality of render will deteriorate. So you can do more settings here. You can increase the exposure, make it warmer or cooler. So these are like some post-production you can do directly in KeyShot. Okay, anyways, so that is gonna be it. That's like a typical workflow that you follow when you have to model and do some parametric stuff and then create a render. How do you decide on the sample? Eugene asks. So Eugene, for a sample, as I told you, when you are configuring your scene, you will get this heads-up display, view heads-up display. Okay, and here you will see this sample number. So whenever you reset your viewport, this sample number will start to calculate one more time. Okay, so as the sample progresses, your render quality improves. Okay, so the longer you let it run, the better quality you will get. But there is like a law of diminishing return. Like, it's not like if you leave it for longer it will always be that better. There comes a time where that is the best it can do, and the next improvement that it does is really insignificant. You won't be even noticing it. So you have to kind of calibrate how many samples it requires, that when you look at it, it doesn't have any noise or it looks the way you want it to. So here you can see probably like 100 samples is too much. Even in 80, 60 samples it was working pretty well. So I will put that sample amount in this part, 60 or 80, etc. Okay, and then press render. All right, so yeah, that's gonna be it. If you have any more questions, how can we emphasize the created parametric pattern in render? Well, you can do that. I mean, in Grasshopper, in KeyShot, you don't have much control because that's the geometry itself. You have to do that in Grasshopper. You might want to reduce the reduce the number of counts, increase their sizes and their depth for the Boolean difference. There is something you can do in KeyShot. So even, let's say you create a new environment. Okay, I'm gonna create a really dark environment, create a light source. Okay, and I need to position this light source in such a way that it falls just slightly tangent to that surface, so that it looks like the holes are really dark, okay, because you're looking at it from a really sharp angle. Okay, that is one way you can kind of emphasize on these patterns in KeyShot. Any more questions? Thank you. Thanks for the detailed walkthrough. Advanced webinar. All right. Yeah, so a couple of things before we call it for today. So guys, if you want to know more about us and what we do, you can check our Academy webpage. In the resource tab, you can always find the previous webinar. Okay, you can see it here. The link is also here. You can download all the files, etc. Okay, and some other resources, and we will keep adding them, especially now onwards. Apart from that, you can also check our paid courses. So here you can see we have courses for Grasshopper. So if you're barely starting with Grasshopper, this course is gonna basically walk you through with the fundamentals of Grasshopper. You will be understanding what is actually happening whenever you create a script, like how Grasshopper works on its core level. And especially we will put a lot of attention on the data tree and everything like that, so that once you are done with the course, you can experiment on your own to create different scripts. And you can see what are the modules that we will see. Then we have the texture course, which is like an advanced Grasshopper course. So for this, you at least need intermediate to advanced knowledge in Grasshopper, and you can learn how to create these parametric textures. Okay, and these textures are NURBS textures. I mean, if you're using CAD software, you might be like kind of surprised on how to create these NURBS textures, because in Mesh it's a lot easier, but in NURBS it takes a lot of effort. So we will learn how to create these textures, playing with the ISO curves, creating these faded lofted textures, creating this surface morph textures, and some of these other interesting textures on your geometry. We will also see how you can import some of your, like some of you don't use Rhino, you use SolidWorks or Fusion, how you can import those geometries to Grasshopper just so that you can apply the texture and go back to your CAD software. Okay, so the difference with doing it in Solid or Rhino even than doing it in Grasshopper is that you create this logic, and when you create this logic, you actually understand a lot better on what is happening behind the scene. Okay, so it kind of clears your a lot of doubts on how to tackle such problems. Apart from that, we have the Rhino course. Okay, so if you're starting with Rhino or you already have some experience, we will go through doing some curvature, like the basics, of course, like Boolean operations, basic geometry, curve, etc. But then we will also dive deep into working with, like some of you were asking, like why not work with degree 5 or degree 7? Yes, that would be the ideal case, so that you don't get this discontinuity on your curvature graph. How to match surfaces so that you can create a really nice surface A quality. Okay, we will also see to create geometries with sub-D workflow or the mesh workflow and some other Rhino tools. Okay, if you're interested, you can check it over here. And finally, we have the KeyShot course. So I have like a trailer video. I'll just play it for you guys. You can of course check the so we have ads, sorry. All right, so here you can see the modules that we will go through the KeyShot workshop. So we will start with the basic materials, like how you can use pre-downloaded or downloaded materials from KeyShot library. We will create our own texture using different PBR material textures and use these utility nodes to kind of modify these textures in a lot more controlled way. We will create lightings, of course, physical lightings, so you have physical geometries to create these really interesting compositions, as well as we will go through the HDRI, that what we were seeing now, like how you can create your own custom HDRI. We will also go through some of the procedural textures and create these algorithmic texture in KeyShot. Okay, you don't need any kind of additional texture map that you need to download from internet to create such textures in KeyShot. Then we will also work with the real cloth node to create photorealistic cloth material, so you can see how these fibers look 3D, as well as have these flyaway fibers coming out from the cloth. We will also see different geometrical nodes like this fuzz node, some of the flakes and bubbles node, okay, and create this complex multi-layer material in KeyShot and learn how you can stack one material on top of the other material and create like really this multi-level advanced material. We will also look through the caustics. Okay, you can create these interesting integrate reflections that happens when you pass a light source through glass or liquid material, and how you can get these deformations. Of course, animation, we will use our OPS concept phone to create this nice animation in KeyShot, like parts as well as camera animation you can see here. And we will go through some additional important KeyShot 10 updates, okay, and utilities that is gonna be really helpful to ease up your workflow. So yeah, you can check our webpage and you can write to us if you have any questions. Okay, let's see if you have any more technical questions. Which graphic card you use for rendering? I actually don't use any graphic card. This rendering is happening in processor and CPU. Okay, so no, I do have a Quadro, but that is actually helpful when I'm modeling in Rhino, but I don't render in graphic card yet. First time seeing Grasshopper, really interesting. Yes, you can check my other channel as well if you're into Grasshopper. So the YouTube channel is called Creative Mutation, and I have some of my webinars for Grasshopper. You can check it over here. Apart from that, can we learn skills of Rhino and Grasshopper from a manufacturing perspective, since we had complaints from factory or CAD/CAM department? Yes, of course, James. If you can resolve most of the problems internally, you don't have to rely upon external entities, and you can, I mean, Grasshopper, don't think about Grasshopper as a CAD modeling software. Grasshopper is a lot more like programming itself, and you can create really weird and interesting workflows. Okay, so this is basically creating a workflow for whatever it is that you're trying to achieve. But yes, you can use Rhino as well as Grasshopper for manufacturing and preparing molds. Then Federico, thank you very much, Aman. Good night. Yes, Federico, you should go to sleep, and really appreciate for you being awake till 4:40 a.m. for just the webinar. Great webinar, Rob. Thank you very much. Yes, it will be available to watch later on. You can just use the same link. Thank you, Sandesh. Very interesting. Previous webinars, yes, you can check the resource page. Manuel, gracias. Neha, thank you very much. All right, guys, I think that's gonna be it. Just let us know if you have any questions. Write to us. and thanks for participating. Okay, hope you have a great weekend, and see you guys in the next webinar. Okay, bye bye, take care guys.